Why are all the Earth's deserts on a similar latitude? And what gives different parts of the world their climates? What gives us jet streams? And why do we get prevailing winds? It's all to do with the global atmospheric circulation caused by the Earth's rotation. We will look at what this is over a series of short explainer videos. The first step to explain how global circulation patterns affect weather and climate is to understand how temperature varies across the globe. Global circulation is caused by different parts of the world heating up differently. In this first video, we will look at what causes this differential heating. The sun is our main source of heat. This heat travels to us through space in the form of radiation. This radiation is absorbed by clouds, atmospheric gases, and by the Earth's surface. Some parts of the Earth receive more of this radiation than others. The main reason for this is the curvature of the Earth. This curvature means that at higher latitudes, the radiation from the sun is spread over a much larger surface area, while the same amount of energy is much more concentrated near the equator. The radiation also travels through a greater depth of atmosphere nearer the poles in comparison to the equator, so more radiation is lost to scattering and absorption by gases and particles in the atmosphere. The tilt of the Earth also means that polar regions do not see daylight during the winter. Here the Earth is continuously sending out heat to space without any compensating incoming heat from the sun. These cold polar regions are where we see lots of snow and ice. Snow and ice, and also thick cloud, reflect a lot of the sun's radiation back into space. The reflectivity, or albedo, of the underlying surface is an important factor in determining how much of the sun's radiation is used for heating the Earth. The combined effect of all of these processes sets up a thermal gradient between the equator and the poles. In fact, the global radiation balance is such that polewards of 40 degrees latitude, the outgoing heat radiation from the Earth exceeds the incoming heat radiation from the sun. Global circulation acts as a clever air conditioning system, redistributing the heat, stopping the equator becoming hotter and hotter and the poles becoming colder and colder, and these locations becoming uninhabitable. This circulation takes the form of 3 large atmospheric cells, which exist in both northern and southern hemispheres. Our next video shows these cells in more detail.